Alright, let's.
I really wanted my hair like 4 times. Only the girl got a blizzard.
Valerie was a risk taker.
Yeah, I wanted to get the blizzard. No, you didn't. Yes, I did. Oh, no, because I didn't want a paper cut. Paper cut.
I've never got a paper
cut. Everybody's got a paper cut.
I'm
aiming at my face. It hurts so bad. I've got
Alright, so if you would put the tops on your marker for just a second, we'll get started in just a second. We are back. 2 days ago, we took a detour so that we could start learning about mixed numbers and improper fractions and going back and forth between those two. Yeah. Yeah, and just a second. Yeah, that's fine. And then yesterday we took a pause to kind of practice a lot of these new things that we've had come along. The nice thing about having a snowball fight in the room is we get to have a snowball fight in the room. The bad part is the next day doesn't seem quite as exciting as the day that you got the snowball fight. So we're gonna be troopers today, and we're gonna trudge on through a regular lesson. Like I said, it might not feel as exciting today, but it's got to happen. We've got to get this one under our belt so we can move on. I think you're going to see what we're doing today, and we're going to fly through it. It's one of those lessons. It's not going to be a problem for anybody, okay? All right, so we're back to lesson 16. So, like, we took this big detour, but we're kind of back on track now. Let's get started with a couple problems. I'm only going to pull a few of these out. All right, let's start right here. Try to list the factors of 26. None of that. Well, one more day and we get a break.
Who, us? What?
Factors of 26. Factor pairs of 26. Seeing quite as many numbers being written down on this one. Do you think this number has a whole bunch of factors? No. It is even though, so we know it's got a few. We know it's not what? It's not that certain number that means it only has 2 factors. It's not prime. Okay. So what would go with 26? Give me 2 factor pairs, yeah? 1 in 26. Can't leave that one out, even though that one gets forgotten a lot of times. 1 in 26. What's another one? 13 and 2. Okay, so you know it's even. You know 2 is in there somewhere. What does it go with? It goes with 13. So 2 and 13. Now, did anybody find any others? With that 6 right there, sometimes it makes us curious if it's, if we can divide it evenly by 3. If you tried that, if you weren't sure, you can't get the 3 into the 2, so I have to think of 26. 3 times anything close to 26? Yeah. 3 times 9 is 27, that's real close. 3 times 8 is 24, which is close, but neither one of them land right on it, so this is not going to work. Okay, so that's it. So even though this one just has two factor pairs, 4 total factors, it's still composite because it has more than 2. Okay. All right. I'm gonna grab this other one right here in the middle and see if you know what to do with that. I'm not even gonna say a word. I just want to see if you know what to do with that. Look closely at it. It's telling you what to do. Go ahead and write that on the board. Alright, so what are they asking you to do? I'm not asking for the answer. What are they wanting you to figure out? Mason? That's part of it. What else do they want you to figure out? What do they want you to figure out? Yeah. Okay, a numerator. What is the symbol that's being shown between those two fractions? Is it a big open bubble or a blank? Because if it were a big open bubble, if we saw 4/6 and then this big open bubble and then a fraction over here, we know we're comparing. What are we doing here? Yeah. That's part of it. What do we call these two? Yeah.
Equivalent.
They're equivalent. There's that equal sign in between them. So we're wanting equivalent fractions. Now y'all all said parts of it that were important. We're trying to see what they multiplied by or could have been divided by. We're trying to find the numerator. We're trying to find that missing piece of a fraction that's equal to 4/6. How do we do that? Well, we know we can do multiplication or division to get there. So what did you do to get from here to here? What did you do? We multiplied by 3. 6 multiplied by 3 is 18. So what is 4 times 3? Everybody. 12. Okay. So they were multiplying by 3. So it's like we've left this kind of stuff for a while, and then we're going to see it show up every now and then. We just still need to know what to do. And I think y'all did. I'm just trying to get you to put it into words. Okay? All right, let's leave that for now. Well, so disappointing. You were supposed to be gone. Is this a new one? Like, is this something you've done recently? Okay, that's progress. Except now it's not letting me throw it away. Huh.
Make it smaller.
Yeah, that's what I'm going to do.
No, what? No.
It's not like, you know what, though, when I do this, I feel like I'm some superhero, and my superpower is to shrink things. Ha ha ha.
Stop doing it. No. Stop it. No.
Yay.
Stop in the name of the paper.
Yay.
Stop it. No.
Will that go away?
No. Stop
Yay.
it.
Will that go away? Go away? Go away? Go away?
Yay, Miss Wendy.
Top one.
Miss Wendy have saved the day. There's more in the corner. There's more in that corner.
Yeah, well, we're going to leave it alone because I'm good now. All right. So if I put this on the board, if I put that on the board, y'all might be a little nervous that this was going to be a little hard. But I want us to say this a little differently. Okay, so go ahead and clear off your board. Put the top on your marker, lay it down. Okay. All right, so this says 5 minus 4, but there are other ways to say that. Like if I asked you to include the unit. Okay, we hear that word every now and then. We heard that word a lot back in place value. Okay, what am I talking about when I say what's the unit? We might hear that word when we round sometimes. What's the unit? Yeah. That's exactly what I'm talking about. Tens, ones, hundreds. So what is the unit for these numbers right here? They're ones. They're not big enough to be tens or hundreds or any of those. So if I asked you to say this with the unit, how would you say it? Anybody want to take a
Wait, what?
take a try?
5 ones and 4 ones?
Yeah, 5 ones minus 4 ones is equal to 1 1. 1 1. 1 1. Yeah, okay. If I said let's change the unit. Let's change it to markers. Okay.
Here, I got some.
5 markers. Okay, who can say it with the word markers? Go ahead.
5 markers. Oh.
Good job. Keep going. You're going to say that whole thing.
5 markers minus 4 markers.
Okay. And I know we don't have the equal sign up there, but it would be equals 1 marker. Okay. So 5 markers minus 4 markers equals 1 marker. 5 ones minus 4 ones equals 1 1. Okay. I don't always have 5 of everything that's up here, but what if I had, what about with this? What if this was the unit? Say this now with the unit.
5.
Try. Give it a try. Yeah.
5 suckers
Mhm.
minus 4 suckers.
This isn't hard. It's just, what is she doing? What is she talking about?
Little
5 suckers minus 4 suckers. Like if we had a word problem. You know, Susie went to the store and bought 5 suckers. She took them home and gave 4 of them away to her friends. You know, what's the math problem that would go with it? 5 suckers minus 4 suckers. Okay.
Sandwiches.
Yeah, Reagan, what would it be?
5 sandwiches minus 4 sandwiches equals 1 sandwich.
Miss Wendy was really, really hungry at lunch one day. She brought 5 sandwiches. She ate 4 sandwiches and only had 1 sandwich left. So what's the math problem? 5 sandwiches minus 4 sandwiches equals 1 sandwich. Okay. We could go on and on, couldn't we? We could make a number sentence with any unit. 5 apples minus 4 apples is 1 apple. You know, we could go on and on. What if we wanted to get a little mathy? Ooh, okay. Hate to get mathy in math time, but you know. What if we said inches, like if we were measuring something? What would it be? Ishmael, can you?
5 inches minus 4 inches.
Yeah, 5 inches minus 4 inches, like if we were trying to measure something. What if we even went 4th grade math? Well, inches is 4th grade math, but later. What if we said sixths? Now she done it. Now she's getting into fractions. Come on, it's Friday. I gotta.
4 sticks.
There. Okay, you just woke up. All right, read it for us with 6.
4 6.
No, read it for us with 6. Take 2.
Oh. 6. I got it. Mine is 4.
Okay, let's take 3. Here we go.
Oh,
What is that number?
5.
Thank you.
5.
5.
Minus.
Okay. Read it with 6. Okay.
A baby could lose.
Put the word. Okay. All right. Faith, help him out.
5, 6 minus 4, 6.
Okay. There we go. There we go. All right. Now, what if we stuck with that? And let's say we have a number line. Now, all right. Let's say we have a number line, and we're going to start that number line at 0. We'll end it at 1. Okay. And let's grab onto that unit that we were just using. Guys, put everything down right now. Okay. We're going to cut this into 6. Okay. And what if we tried to show this? Okay. What if we went with what we just said? Faith read it for us, 5, 6 minus 4, 6. Okay. So this is cut into 6. Let's find where 5, 6 even is. So without labeling every single one, I could just count up to that. So we got 1, 2, 3, 4. 5, 6 would land right here. Okay, y'all see that? It's just very easy to show on the number line. Okay, this is 5, 6. We'll label it. Now, how could we show on a number line that we're going to take away 4 of those 6? What's something we could do to show we're taking 4 of them away? What do you think?
You could draw arrow back 4 spaces.
Arrow back 4 spaces. Is that what you're going to say? Okay. Same thought there. Any other thoughts?
You could.
So if that is our starting spot, we might show that we're taking 4 of these away. 1, 2, 3, and then 4. And where would we land? If we know that's our landing spot, where did we land?
1, 6.
We landed on 1, 6, because if I count those up, that's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So just with a simple, here's where I start, and a simple hopping back, I've done a math problem on a number line. Okay, I have done 5, 6 minus 4 of those 6. Okay. That is one of the things we're doing today. We are subtracting and adding fractions. Okay. I can use visual models. Our visual model we used this time was a number line. To add and subtract 2 fractions with the same units. Now this is hugely important. With the same units. When we started out, we kept saying that same number sentence over and over. 5, what did we say? 5 ones minus 4 ones. 5 suckers minus 4 suckers. 5, what else do we? 5 sandwiches minus 4 sandwiches. Then we turned it to math. 5 inches minus 4 inches. 5, 6 minus 4, 6. Every single time we did that, what? Every single time we said one of those problems, there was something that they had in common. Yep.
They subtracted by 4 every single time.
We did. We kept the same numbers. But what else could we say?
We got 1 as the answer every time.
We got 1 as the answer every time. These are things we have in common. But there's something I'm looking for you to get that was in common every single time. Yeah.
They had the same denominator?
They did, in a sense. Now this is what we mean. When we turn to fractions, we had the same denominator. We call it a denominator. But before that, when I had the suckers, were we trying to take apples away from suckers? No. Where's my? Were we trying to take dogs away from sandwiches? No. That would be difficult, would it not? Actually, to try and take a sandwich away from a dog is actually probably harder. But anyway, I'm learning that at my house with the new puppy. If we had apples, if I said, here's 5 suckers, would you take 4 apples away from it? You might look at me like, I don't get what she's talking about. I don't know how to do that. Because what?
You don't have any apples.
You don't have any. They're two different things. It doesn't make any sense. Okay? So in the world of fractions, taking away, if we were doing adding or subtracting and the denominators were different, okay, can we do it? Yes. Very simply, like we've been doing? No, there's some steps you have to take. You have to find your way to a common denominator. That helps a whole lot. Okay, we're going to do that later. But right now we've got the easy stuff. We get to subtract and add with like denominators. That means the denominators are the same. Okay. Now, if you can ever get your math problem to where your denominators are the same, you got it made. It's so much easier. And today we get the easy part. We just get to see how it works with adding and subtracting fractions when the denominator is the same. Okay. All right. So if we had this problem, 5/6 minus 4/6. What if you had this and you didn't have a number line? Do you think you could write the answer? I think you could. Because I watched you do a bunch of number bonds over the last few days, and there's a lot of adding and subtracting with number bonds that we don't even realize that's what we're doing. What is the answer here? What's the answer here? Everybody should be able to tell me at this point. 1/6. Okay. If I have 5/6, I take 4 of those 6 away. I have 1/6 left. All right. Remember this type of thing over the last few days? This is another visual model. Okay. If I have 4 of the 6 right here, what does this other piece have to be? Yeah, 1/6. Because these things right here add together to make this. We know how a number bond works. Okay. All right. So kind of getting us started with adding and subtracting fractions. Now, that was subtracting. We're going to see adding too, but they both work pretty much the same way. That you can just guys, it just turns into regular old subtraction, regular old addition if you have the same denominator. Okay. All right, so let's show it though with a few different models a few times, and then we're going to switch to where we're not using the models. Yeah. Probably. I don't know if that'll happen today. But yeah, we'll get larger. We just usually start simple. Okay, so get your marker, and we're going to draw a number line from 0 to 1. Okay. All right, so that's all you know right now that you have. You don't know how to cut the number line yet. Okay. Here is the math problem that we're going to work with. Okay. So let's help each other here. If that's the math problem that we're all fixing to work with, let me have your eyes. How are we going to set up our number line? We got to get our number line kind of ready before we can do the math on the number line. What do you think? Yes. How did you know that? Okay. This right here is so important for so many reasons. But Ishmael noticed what the denominator was. That is going to tell you how to get your number line ready. If we're working with 8s, we're subtracting 8s. We need 8s in our number line. So cut your number line into 8 pieces, cut it in half, and then you need 4 pieces on each side of the half. Okay. All right. Now, what do you think we need to do first? It does have tape over the little thing that sticks out so that this won't happen. Thank you.
Yes, sir. And I will.
All right. So we have a number line. So do I need to keep it open?
Well, you should, it come like that.
It won't unlock.
Yeah, I can get it unlocked, but
Okay, we'll get it. Thank you. That right there helps. Guys, don't mess with the door. Don't move the broom. You know, sometimes we do something like that. Oh, I'm just being helpful. Let me move the broom out of the way. Don't move the broom. Okay. All right, so let's get back to what we're doing. We got a number line. Got it cut in 8 pieces. How do we start? I know you know how to do subtraction. What I'm asking you is, how do we start showing this on the number line? What would you do first? What do you think would be helpful? Yeah.
Look for 7, 8.
Absolutely. Let's find this starting spot right here. So count over to 7/8. That space is 1, 2, 3, 4, 5, 6, 7, and put a dot there. Let's label it as 7/8 so that we're showing what we're doing. You know what? Probably easier to just count backwards because it's just 1 away from 8/8. You could do it that way too. Anyway, how are we going to show minus 3/8?
Go back.
We're going to show us hopping back 3/8, 3 spaces. So I just subtracted 1/8. I subtracted 2/8. I subtracted 3/8. And do you already know what the answer is going to be? Yeah, what's the answer going to be? What? 4/8. Okay. This is going to equal 4/8. Is that where we landed? 1, 2, 3, 4. Sure it is. Now I'm looking at that, and if that's all I had, I would not be able to tell if you added or if you subtracted. You see what I mean? I can't. It's hard for me to tell which direction we're going on the. So what is there something we could do? This is not necessarily a have to. Mason, what are you gonna say? Okay, like right -1, you could, or you could just kind of draw an arrow like that, show which direction you're going in. Okay, that's not a have to. Do you see how that almost looked like we could have been adding or subtracting, depending on which way we were hopping down the number line. Okay. Now we're practicing this, guys, simply because you might be asked at some point, do the math, but also show it with a model. Okay, so I want you to know how to do that on a number line. A lot of times, though, you're just going to be given this right here. You're just going to be given a problem. Sometimes the directions are going to tell you to show a model. All right, so what if we kept it in unit form? Okay, let's write this on our board. 10/6 minus 2/6. Stay with me a little bit longer. We are almost at the end here. Okay. Yeah, include the words this time. Okay. Now, some of you automatically wrote it as a fraction, and I love that you did. I want you to write it with the words this time. We rarely use the unit form like this, but let's just do it this one time. I think on your problem set, there's a few problems like this where all you have to do is write the answer with the unit word, okay? What would our answer be? If I have 10/6, and I subtract 2/6, okay? Valerie, what's my answer going to be? 8/6. And if they want it written in unit form, you would need to write 8 and then the word 6ths. Okay. Now, these directions ask you to take the answer. Look at, use a number bond to rename an answer. Guys, you're going to see that on your problem set today. Where you finish a problem, and if your answer is an improper fraction, you've got to change it to a mixed number. Well, that's hard to do in unit form, so I am going to take that fraction 8/6 and I'm going to write it as a fraction. Okay, go ahead and write 8/6 as a fraction, and then use your number bond to change it to a mixed number. All right, how many 6/6 can you pull out of there? That would give you your whole number, and then what's left over. This is what we did yesterday. Okay. How many 6/6 can we pull out of there? What do you think? Alex, how many did you pull out? Just one time. How many are left over after we do that? Faith, how many? We pull out 6/6. 8 take away 6. How many are left? 2 6. So our answer is going to be what? Oh, that's not a whole number, but what's our answer?
1 and 2 6.
1 and 2 6. Okay. So today, this might take you longer than the actual adding or subtracting part. Okay. All right, just so that we can say we have seen the addition as well. I'm going to clear off your board, and we're going to put one more number line on there from 0 to 1. Go ahead and cut it into 8 pieces. Go ahead and cut your number line into 8 pieces. How would we start this one? How could you show this adding on the number line? Where would you start? Yeah.
With 3/8.
Okay. You could start with 3/8, or you could start with 2/8. I'm going to start with 2/8 just because I'm going in that order. All right, so label 2/8. And then we're going to show how many times we travel down the number line. We're going to add 3/8, so we're going to jump down 3 of these 8s. Now don't put 3/8 at the top of that spot. Where did we land? We started at 2/8, we went down 3 more. Where are we now? Yeah, 5/8, sure. Y'all know, y'all already knew this was 5/8. I know that. We're just practicing showing it on a number line. What does that look like? Okay. Huh?
I said now I get it. At first I didn't really get it.
Gotcha.
But now I do.
The number line really becomes kind of easy to use when you're doing adding and subtracting a fraction. Okay. All right. What questions do you have about this? Is there a part of this that we're confused by? We might need it to be a little clearer. This is pretty simple. It's pretty straightforward. Okay. So if we had 5/4 and we added 2/4, what would our answer be? Without a number line, what would our answer be? Okay, Kennedy, what would our answer be? We got 5, we add 2 more. Huh? Let's say super loud. Not 8, 5, 2 more. 7/4. Okay. All right, it's not going to be okay to leave our answer as an improper fraction today. So if we've got 7/4, I need to know what our mixed number answer is. So go ahead and change that. What is 7/4 when we change it to a mixed number? What is it?
1 3/4.
Anybody else get 1 3/4? I can pull 4/4 out one time, and when I do, I'm left with 3/4. So this becomes 1 3/4. Okay. All right. We are going to head into our problem set and pick some of those problems to work.